Hi everybody, it's Miss Phoebus again, and this is Lesson 1, Solving Multi-Step Equations and Special Solutions. Please make sure you're watching these videos. They go with the slideshow. The slideshow is more for you to make sure that you can see everything. I know sometimes the camera is not right, or I might be in the way, or something like that. So that kind of helps you set up your notes, and I really encourage you to take notes. You need to get your pencil on the paper, and you need to be writing stuff down, practicing these problems. You're going to get a lot more out of it. It's going to stick with you if you're taking notes. All right. So we're going to start with vocabulary. Now, you can't really see me, but we're going to start with vocabulary. And so what I want you to do is I want you to make a table, kind of like this, and I want you to write words I know and words I don't know. And we're going to kind of do that at the beginning of every lesson because vocabulary is important. Vocabulary, being able to know what words mean when I'm using them, and that way you don't get confused. It's important, right? And there's a lot of math vocabulary. So these are the words that go along with today's lesson. So you need to pause the video and sort them into words I know and words I don't know. Coefficient, constant, equation, distributive property, reciprocal, infinitely many solutions, and no solution. Once you have them in the table, I want you to take the words I don't know, and I want you to write down the definition. So I want you to do definition so that when you come across these words again, you're able to look them up. So here we have coefficient. A coefficient is basically a number in front of a variable. They're basically being multiplied. So in 4x squared, 4 is the coefficient. A constant is usually just a number. Sometimes it is given a variable value, but most of the time you're just looking at, like, in this case, x plus 5 equals 9. 5 is just a number, so it's a constant. 9 is just a number, it's a constant. An equation is a statement of values and mathematical expressions that are equal. You're going to know it's an equation because it has an equal sign. If it doesn't have an equal sign, it's probably an expression. All right? The distributive property and the reciprocal, I talked about both of those in lesson 0 videos. Distributive property allows you to take two things that are being added and you can multiply each piece by something. So we can distribute that A to both of those and have AB plus AC. Reciprocal is basically taking a fraction and flipping it upside down. So 2/3 becomes 3/2. Infinitely many solutions and no solution go with our special solutions today that we're going to talk about at the end of the video. So basically you're going to use infinitely many solutions when you go to solve for a variable and that variable completely disappears and you're left with something like 25 equals 25. When that happens, you're going to be like, ooh, 25 equals 25. It's a true statement, and then you have to say infinitely many solutions. No solution, same boat. Your variable is going to disappear when you start solving the equation, but you're going to get something weird at the end, like 0 equals 7, or 5 equals 2, or something like that. And when you get that no variable in it, you're going to be like, that's not true, and then you're going to write no solution. Okay, so those are your special solutions there. All right, your learning goals for this lesson, that you can solve linear equations with one variable no matter what I throw at you. All kinds of distributive property, all kinds of stuff. And then you can identify when an equation has no solution, one solution, no solutions, or infinitely many solutions. So it's in one of those categories when you solve it. All right, these are the standards that we are covering today. We're looking at coefficients, being able to identify a coefficient so we know what it is, solve linear equations in one variable. The other stuff, the inequalities and this equations with coefficients, we're going to talk about that later. All right, DCMAM. Be like, what am I looking at? All right, this is a mnemonic. A mnemonic is a kind of a phrase or a sentence that you can use to help you remember something. So here is our mnemonic. Don't call me after midnight. Really, don't call me after midnight. I'm asleep. Okay, but that doesn't sound like any kind of math, right? So don't call me after midnight is supposed to help you remember. Here's the mathy stuff. Distributive property comes first. Combining like terms comes second. Move the variable, add, subtract, multiply, divide. This is kind of like the order of operations. It does have kind of an order flow to it, but not everything necessarily has to be used. You don't always have to do the distributive property. If there's nothing there to distribute, you move on. These two are kind of interchangeable. There's going to be some times when you might have to multiply or divide first and then add or subtract. So just keep that in mind that these two are kind of changed. But I always start with distributive property and combine like terms and then move the variable. You're going to see me practice those. Alright, so here's our first one. Here I've got mine, DC ma'am. That's what it looks like. Distributive property, combine like terms, move the variable, add, subtract, multiply, divide. And here's our first problem. I'm going to work this one out. The next one's going to be yours. So, my very first thing is, do I have the distributive property? I don't see any parentheses in there. I am not using the distributive property. Well, how about combining like terms? Well, when you combine like terms, I'm going to split where that equal sign is. I'm going to split this equation into two pieces. I've got left of the equal sign and right of the equal sign. And I'm looking for things that I can combine on the left-hand side or on the right-hand side. So I'm looking for like terms, like two things that have the same variable, or two constants, two things that are just numbers. Here I have a variable and a constant. Can't add them together, not like terms. Here I have a constant and a variable. Can't subtract them, not like terms. So I can't do distributive property, can't do combine like terms. So now I'm on to, can I move the variable? And yes, I can. Now you are going to end up with some options. Do I want to move the negative 5p over here? Or do I want to move the negative 9p over here? Whichever way you choose, as long as you move it correctly, doesn't really matter. So I'm going to move the negative 9p over. I like making my p-value, my variable value, positive. That's just what I like to do. So I'm going to do the opposite operation, or the inverse operation. I see subtract 9p. The inverse of subtract is add. So I'm going to add 9p to both sides. And when I do that, I get the 0 pair that I can cancel out. And negative 5p plus 9p is 4p plus 13 equals 17. Alright, now, so I did that, I moved my variable. Now I'm going to look to see, can I add and subtract? And I can. I have this constant that needs to be moved. Needs to be moved away from the variable. I see a plus 13, so the opposite of adding 13 is subtracting 13 on both sides. So I have 4p equals 17 minus 13 is 4. So I did my addition, subtraction. And now I'm going to look to see, can I multiply or divide? So I have 4 times p. Opposite of multiplying by p is dividing by p. 4 divided by 4 is 1, so I've got 1p. 4 divided by 4 is 1. There's my answer. Now, you can check. I don't require a check, but you can check. And you can check by plugging into the original. So I'm going to plug in negative 5 times 1 plus 13. Well, negative 5 times 1 is negative 5. Negative 5 plus 13 is 8. Alright, let's plug it into the other side. 17 minus 9 times 1. 9 times 1 is 9, so 17 minus 9. 17 minus 9 is also 8. So this checks out. These are the same. Now, be very careful, because we already talked about in the vocabulary, when you see something like this, that means that it's true, that it's infinitely many solutions. If that was the solution to the equation, this is not the solution to the equation, this is the check. Okay? This is the solution, and there is only one of them. There is one solution, because I have a variable equaling one number, one solution to this equation. So don't get confused if you're checking and you get here. I've had people in the past check this, and then they're like, ooh, infinitely many solutions. I'm like, whoa, 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 what happened to this one? There's so many, infinitely many solutions means that there's so many numbers that work that you can't even count them. All numbers work. If I plug in 0, I get 13 equals 17. That doesn't work. So there's one solution. Only one will work. Okay, so keep that in mind. Alright, number 2 is yours. Pause the video, try it out, see what you can do. Alright, So we are going to check to see, can we do the distributive property? Can we combine like terms? Nope. Can I move the variable? Yes. So let's move the variable. I'm going to move the 2x. I'm going to subtract it on both sides. I have a 0 pair right there, cancels out. 6x minus 2x is 4x. The minus 4 doesn't change. The plus 8 doesn't change. Okay. And then I'm going to, so I did move my variable. Now I'm going to add or subtract. I have a 4 that needs to be moved, a negative 4 actually. I'm going to do the opposite of minus 4. I'm going to add 4 to both sides. And remember, you got to keep this balanced. If you only do something on one side of the equal sign and not to the other, it's not going to stay balanced. So there's my 0 pair. 4x equals 12. And then that's 4 times x. So divide by 4. That's the inverse operation. So I would add, and then I'm dividing. So I'm getting both of those in there. X equals 30. And that is one solution. Okay, if I plug 3 back in, I should get something that's true, a true statement. All right. Let's look at number 3. All right, this one's mine. So, looks like we need the distributive property. And how do I know that? Because I got these parentheses right here and right here. So I'm going to distribute. Now, one of the most common errors that's made with the distributive property is that you multiply the 2 times the first piece, but you don't multiply the 2 times the second piece. So you got to make sure, however many things are in the parentheses, they all get multiplied by the number on the outside. So I'm going to go ahead and distribute on both sides of this equal sign. 2 times 8a is 16a, minus 2 times 2 is 4, 5 times a is 5a, and 5 times negative 3 is negative 15. And then I'm going to subtract 5a. There's my 0 pair. 16 minus 5 is 11a equals, minus 4 equals, now watch out for this, okay? See that minus in front of that 15? That needs to be kept as a negative 15. ACT loves that kind of stuff. They want to see, do you keep up with all your negatives? And that is a common mistake. So if you drop that negative and turn that into a positive 15, you're going to get the wrong answer. All right, so I did my distributive property. I don't have any like terms to combine. I moved my variable. I'm going to move this subtraction, change it to addition. So I've got 11a equals negative 15 plus 4 is negative 11. So I took care of my addition. And then there's multiplication here, so I will divide by 11, a equals negative 1. So watch out for that. Don't lose that negative on that 15. Make sure you don't lose your variable. Make sure you're being very, very careful and paying close attention to detail so you don't lose anything. It's one of those things you're going to have to double check each line. Now, let's talk about Canvas. Let's talk about maybe in the next time that you submit homework, what you might see, because I want to see your work, right? So what I might see, or what I might give you is this, and then I might want to start seeing, you type this, and this, and this, and this. Okay? So when we go to Canvas, you're not really showing me the in-between that you subtracted 5, that you added 4. But in these pieces, I see that evidence. Okay? So think about that as we start moving to put your homework into Canvas, that you want to probably be following along. And I'm going to show you the math type, how to do that in the Canvas. So there's a button in the essay part, because it's going to probably be an essay that you can hit that looks like this. It looks like square root x. And so you hit that button, and a whole new window opens up, and it allows you to type it in. It makes it look fancy. It italicizes the variables. It allows you to do like squares and fractions. That's probably a key feature. You don't necessarily, especially for this problem, you don't necessarily need it. But if you're doing something fancy with fractions or towers or something like that, you might want it. Just keep that in mind. All right, your turn for number 4. Pause the video. All right, you're back. Let's look. We're going to distribute here. We're going to distribute here, but not to that 5. Don't distribute that because it's not in the parentheses. So watch out for that. So we're only going to distribute that 8 to what's in the parentheses. So I'm doing the distributive property. I'm going to have -3. A negative times a negative is a positive. 12, I think that's a V. If you wrote U, that's okay. Equals 8 times negative V is negative 8V. Plus 8 times 4 is 32. And then that plus 5 is just kind of tacked on at the end. It is hanging out just a number. Now, we have the ability right now to combine like terms. These guys are like terms. They're both constants. I can add them together. So I'm going to go ahead and do that. Now, technically, you could do it later. You could move the variable. You could do some different stuff. But at some point, you have to combine them. So let's go ahead and combine them now. So -3 plus 12V equals -8V plus 37. And then I'm going to move my variable. I'm going to move this -8V. I'm going to add 8V. There's my 0 pair. -3 plus 20V equals 37. I'm going to move with addition. I'm going to move this -3. I'm going to add it to both sides. So I get 20V equals 40. And then I'm going to do my division, because I see multiply by 20. I'm going to divide by 20. So I get V equals 2. In case you couldn't see it, I think it's down at the bottom. Alright, so we did all of these. We did the distributive property, combine like terms, moved the variable, we did some addition, and then we did some division. So we did them all. But that's not always the case. Sometimes you only do some of them. So just keep that in mind. Alright, I think I got another one. Yay, we got a fraction! Woo! I'm sure you're excited. Now, there's actually 2 ways to do this. One way is to distribute, but I'll go ahead and tell you you're going to have fractions everywhere. So, I want to show you a little trick. Especially if you don't like fractions, you might like this trick. Now, notice that I've got 3/4 times my parentheses, right? And how do I undo multiply by 3/4? Well, most of you would say divide by 3/4. And technically you're right, but in this class, we do not divide by fractions. We just don't do it. It's messy, okay? Because if I do this, are you any better off? No, that makes you want to cry. Okay? It makes me want to cry. It might not make you want to cry. It makes me want to cry. That's very sad. So, instead of dividing by fractions, we multiply by the reciprocal. The reciprocal of 3/4 is 4/3. So I'm going to multiply by 4/3 here and by 4/3 here. 4 times 3 is 12. 3 times 4 is 12. We end up with 12 divided by 12, which is 1. So this and this cancel each other out. There's really a 1 in front. But if there's a 1 in front, 1 times n isn't going to change anything. 1 times 3 isn't going to change anything. So I'm still dealing with 1 plus 3. Nah, that's not a 1. That's an n. 1n plus 3, or n plus 3. Sorry about that. Alright? This is really 9 over 1, so remember that when we multiply fractions, we multiply numerators, we multiply denominators. There is that little simplification trick. 9 over 3 is the same as 3 over 1. Okay, so you can do that, or 9 times 4 is 36, which is divisible by 3. But 3 times 4 is 12 over 1, which is just 12. And then subtract the 3, so n equals 9. Okay, so that's one way to do it. I want to work it another way, so I'm going to do 3/4, I'm going to write it over here. N plus 3 equals 9. I'm going to do it again, but I'm going to show you the distributive property, okay? And then you can make the decision on what's the best. So I'm going to distribute, and I'm going to have 3/4 n. Oops. Can you read that? You can read it, right? n, at least it looks like you could, and then I'm going to have to multiply. So 3 times 3 is 9, over 4 times 1 is 4, equals 9. Not too bad, we still have a fraction. We're going to have to subtract that fraction. And 9 minus 9/4, some of you want to reach for the calculator. Try not to. I can rewrite 9 as something divided by 4. 9 is 36 divided by 4. So I've got 3/4 n equals, actually I have two fractions, I didn't know that. 36 minus 9 is 27/4. And then now we're going to do the reciprocal thing again. Multiply by 4/3. Multiply by 4/3. These guys don't have to worry about. 4 over 4 don't have to worry about. So you're really dealing with 27 divided by 3, which is 9. Now, which of these looks simpler? My personal opinion, I like the first one. I'm still having to get rid of that fraction with multiplying by the reciprocal, because I'll go ahead and tell you 27/4 divided by 3/4 is not, that doesn't look friendly, right? But here we got rid of the fraction and we were dealing with things that weren't too bad. So just something to think about. I encourage you to work on your fraction multiplication. Try to stick with, or try to not do fraction division. And try something like this. So I want you to try the multiply by the reciprocal. I want you to do that in the next problem. Alright, so you could distribute, but you're going to end up in the same boat that we were in last time, where you're going to have to multiply 3 halves. This doesn't turn out very nice math type wise. Can't get it to turn into one of those little fractions. But this is 3 over 2. And when you multiply by 7, you just end up with, what, 21 over 2, so it's not any better. So what I would do, and you can also rewrite it if you like. Some people like to write, the variable on the left. If that's you, then go for it. But I'm going to multiply both sides by 2/3, because that's the reciprocal of 3 over 2. 2 times 3 is 6. Over 3 times 2 is 6. 6 divided by 6 is 1. Don't have to worry about it anymore. So I get b plus 7 equals 6 times 2 is 32 over 3. That's not going to reduce. And I'm about to subtract 7. So I want to do something. Can I rewrite 7 as something over 3? Well, that's 21 over 3, right? So, let's see. I'm going to subtract 21/3. Mixed up my markers and confused myself. So, b equals 32 minus 21 is 11/3. Okay? Now, some of you, I've already had issues with, you want to write that as a decimal. We're going to be here all day. That's what? 3 and 2/3. So get ready to write 3.66666 forever. And if I do write this as 3 and 2/3 or 3.66667 or whatever, I've had to do an extra step. I really have. So if I don't do that and I stop right here, I've actually saved myself time and effort and don't have to reach for a calculator or break out long division or anything like that. I love improper fractions because they save me time. And time is money, isn't it? So just keep that in mind in the future. I love improper fractions. I love improper fractions. Not proper fractions. Alright, we're going to look at a few of these. I want you to pause the video, see if you can find the error. Alright, so I am a big fan of error analysis. Error analysis is where you go through and you look. I really want my face to be on this where you can see me. Where you go through and you look for all the errors. Because One of the reasons why is because they use it a lot on state testing. But the other thing that I like about it is that really when you make a mistake, you should be using error analysis. You should be going through and trying to figure out what you did wrong. So you go line by line and try to figure out from here to here what happened, what changed, is there something wrong in it? I do it all the time when I'm checking you guys your work, or I will in the future. So I will be looking for, okay, the answer was wrong, and we can know by checking it, it's wrong, why is it wrong? That's the key. All right, so in this one, 4 was not distributed properly. They did not take that 4 and distribute it to both terms. They did 4 times 1 is 4. 4 times 5 is 5. Did you know that? It's not. It's not 5. 4 times 5 is 20, so that should have been a 20t. So what we're going to do on your paper, you should follow along and see if we can fix it. So 4 times 1 is 4, plus 5 times 4 is 20t, minus 8t, equals negative 6t minus 14. I'm going to combine like terms. So 4 plus 20 minus 8 is 12t. See how I like to make my t curve? And that's just a plus, so I can tell the difference. Negative 6t minus 14. And then I'm going to move my variable, so I'm going to add 6t. I'm going to start trying to write tinier. 4 plus 18t equals negative 14. Watch out for that negative, or else you could be a part of the next error analysis. We're going to subtract 4. So 18t equals negative 18. And I'm going to end up dividing by 18. I don't know if you can see that, but it's there. Try changing colors. You see that now? Maybe, maybe not. I don't know. But then t equals negative 1. So definitely a different answer. Okay? So error analysis, which you probably will see maybe on your first test and throughout your homeworks, somebody made a mistake. Where is it? So just keep that in mind. Is something that I like to use. Okay? And notice that, you know, in this you don't see, remember how I was talking about getting things into Canvas? You don't see their work. You don't see like the add 14 to both sides or the add 6t to both sides. You don't see those little things, but this is kind of how it's going to look like when you put it in Canvas. And it doesn't have to be centered. I'm not worried about that. I'm worried about from here to here, did you make a legal algebra move? From here to here, did you make a legal move? From here to here, are you using good math? Okay? And I can look at these pieces and figure out if you did. All right, let's try another one. Pause the video so you can find the error. All right, so the error is we're moving the variable and the constant across the equal sign. The inverse operations weren't used. So here they combine like terms, okay, but when they move this negative 3g over, it's almost like they have 8 minus 3 to get this 5. And same thing goes for this 12. When they move the 12 over, they should be subtracting 12. 32 minus 12 is not 46. 34 plus 12 is 46. So they didn't use inverse operations. So let's fix it. Now we don't have to go all the way back because their first step was right. We're going to pick up right there. Okay? So I'm going to write 8g plus 12 equals, oops, lost the negative, negative 3g plus 34. Negative 3g plus 34. All right, I'm going to add 3g. 8g plus 3g is 11g. And then I'm going to subtract 12. Remember, we're doing inverse operations. So 11g equals 22. Yep. Divide by 11. So g equals 2. Definitely not 46 fifths. Okay? So, error analysis, paying attention, going line by line, saying what happened, what did they do, and is that right? And if it's not right, we stop right there, we go, whoa, we found something that's not right, and then we fix it. Okay? So, when you get your tests, error analysis is a little bit better when you're dealing with paper pencil for yourself. So like if you get a test back and you got the wrong answer, error analysis is really important for you to go back and look at your work and what did you do. You might be able to, if you like keep your notes that you used, or keep your work that you used for a test during this virtual time. All right, pause the video, see what's wrong. Okay, so this one happens a lot, especially at the beginning of the year, because people, they love to combine like terms before distributing, I guess. So the problem was that they combined the 5 and the 10, and then they distributed that. You don't do that. You do the distributive property and then combine like terms, right? Don't call me after midnight. Distributive property first, then combine like terms. So that happens a lot. We need to fix it. Okay? So we've got 5 plus, let's go ahead and do the distributive property. 10 times C is 10C. 10 times 2 is 20 equals 25. We're going to combine like terms. Now we combine these guys. So we get 10C plus 25 equals 25, and we're going to solve for C. So we're going to subtract 25. And right about here, I have some people, usually, they go, ah! I can't do anything. There's a 0. Or sometimes they don't even put 0. They're afraid to put 0. 0 is a perfectly fine number. Now, you are not allowed to divide by 0, but that's not what we're about to divide by. It's 10 times C. So we're going to divide by 10. And you can divide 0 by any number other than 0. And that's just going to be 0. And 0 is a perfectly fine answer. 0 isn't always the answer, but 0 is a perfectly fine answer if it pops up. So just keep that in mind. All right, we're going to do some special equations. So when do you use no solution? When the answer is a false statement. If you end up with something like 3 equals 5, 11 equals 0, something like that, you're going to have to use no solution. And both of these pieces are the answer. So if you give me 3 equals 5, sometimes people even put a line there, 3 does not equal 5, which is also true, and they don't say no solution, you lost some points. If you just say no solution and you don't tell me what made you say no solution, also lose points. You want both of these. Both of these are answers. So they both contribute to getting answers to the problem. When do you use infinitely many solutions? When the answer is a true statement. 11 equals 11. 500 equals 500. Something that they're the same on both sides. So again, you need this piece and you need infinitely many solutions. Now that's kind of long. I'm going to show you how you can abbreviate it. Alright, now, in the next few problems, I'm going to go ahead and tell you if it has one, no, or infinitely many solutions. Okay? But you don't always get that. So just keep that in mind. I keep saying keep that in mind as well. A lot. Alright, this one has one solution. That means at the end I will have a variable equals a number. Okay? So variable equals a number is what I'm expecting because I've already given myself that hint. But just looking at it, you have no clue. None. So you have to work it out. So let's work on combining. There's a lot of stuff up here. Okay, so I'm going to look at the left-hand side. On the left-hand side, I can combine like terms. I have 2 variables here I'm going to be able to combine. But on the right-hand side, I really need to do the distributive properties. So I'm going to kind of treat the left-hand side and the right-hand side separate. I'm going to do combine like terms over here because that's something that I can do. And then over here, I'm going to do the distributive property, but I'm going to have to combine like terms later. So I'm still going to have to do this in kind of 2 steps. So I could wait and combine like terms for this guy later, but I still would have to write all this out. I'm just going to go ahead and combine. So 4f plus 3f is 7f. And then there's a plus 3. Equals, and I'm going to distribute here. And I'm going to get negative 3 times negative 5 is a positive 15, and there's an f. Negative 3 times 2 is negative 6. Then I have my minus 11 and my plus 2f. Now I'm going to combine these. I also need to combine my constants. Alright, so let's look again. 7f plus 3 equals 15 plus 2 is 17f. Negative 6 minus 11, negative 17. Now we're down to kind of like one of the very first equations at the very beginning. I've got to move my variable. So I did the distributive property, I combined like terms. This was kind of early, but that's okay because this is a lot easier to write than having to write three terms. Now I'm ready to move my variable. So I'm going to move 7f. So there's my zero pair. 3 equals, oops, I lost my negative. 17 minus 7 is 10f minus 17. And then I'm going to do the opposite of subtracting 17. I'm going to add 17 to both sides. So I'm going to come over here. 20 equals 10f. And then I'm going to divide by 10. So I get 2 equals f. One solution. Variable equals a number. Or number equals a variable. Same thing, but I have one solution. One answer. Okay? The other guys, the no solution and the infinitely many solutions, the variable is going to disappear. Okay? So that means there's no variable in my answer. I'm going to have a special answer. Now, in this one, I've already shown you, it has no solution. The ACT likes to call that the empty set. Means no solution. And this is the symbol for the empty set where you have two of these curly braces and there's nothing inside. This is another symbol. This is the null symbol. It's like a circle with a line through it, almost like don't do this. So all of that means no solution. I'm going to encourage you to use the word no solution. ACT wants you to know the empty set. So it kind of, I'm okay if you use the empty set, but really, like if you see a multiple choice question on one of my tests or something like that, no solution is going to be there, not the empty set. All right, we're going to distribute on the left-hand side, so I'm going to get negative 12z plus 15. On the right-hand side, I don't have to do anything, but you may be noticing that the variable and the coefficient in front of that variable are exactly the same. And that's a good thing to notice. I'm going to go ahead and move the 12z, and it's hard to tell which one's moving because they both turn into zero pairs. They both cancel each other out. And I'm left with, and this is where you make that decision. Is it no solution or is it infinitely many solutions with what's left behind? I have 15 equals 10. 15 does not equal 10. So I physically write, and you physically write, no solution. Now, some of you will not be able to spell solution. I've been doing this for a long time. Solution seems to be a hard word to spell. So I'm okay if you're writing it out. If you write no and abbreviate solution. Try to avoid NS. I'm not a big fan of that. But no solution is your answer. Okay? And you need this. So actually, now that I said that no solution is your answer, actually both of these are your answer because I want to see what made you say no solution. If you think that 2 doesn't equal 2, we got an issue, right? But if you are showing me this and showing me this, then I can see that connection that you have that there. Okay? And you're not just getting mixed up on the wording. All right, last one. This last one for me, I should say, is infinitely many solutions. Sometimes it's referred to as an identity. We're going to get something that's true, a true statement, so something that's the same on both sides. So let's go ahead and work this problem out. Again, when you start with an equation, you're not going to know until you get deep down into that equation whether it's one, infinitely many, no solution. So keep that in mind. All right, so we're going to distribute, and I've got 6x minus 2 plus 10 equals, and then we're going to distribute over here, 6x plus 24 minus 16. I'm going to combine like terms on both sides, so I get 6x plus 8 equals 6x plus 8. And at this point, a lot of you are like, the left-hand side looks like the right-hand side. You could stop there. You could subtract 6x if you wanted to and get 8 equals 8. You could technically subtract 8 and get 0 equals 0. So at any point in time, here or here, or even here, where you notice that they're the same, you can stop and you can write infinitely many solutions. Okay? Now, you want to abbreviate INF, because infinitely gets misspelled a lot too. Many solutions. Okay? And remember, we're probably typing this in Canvas, but when we're doing pencil paper, if you like, we can draw that. That's an infinity. It's actually called a lemniscate, but it's an infinity symbol. So some people do that, or they'll do that infinitely. Most of the time I write this. This is the one that I write. But you need to have at least get it to where it's matching on both sides, and then tell me one of these. Okay? Don't use identity. That's kind of old. We don't use that one too much anymore. You don't see it around too much anymore. Alright, so I'm going to have you try number 10. Pause the video, see what you get. Alright, let's look at this one. We're going to distribute, so I've got 3p minus 12 plus 2p equals 5p minus 9. 3p plus 2p is 5p. And if you notice, I got a 5p on the other side, so we're looking interesting because our 5p's are about to cancel. I get negative 12 equals negative 9. What do you think? True? False? Definitely false. So we're going to write no solution. So you need both of these. I guess technically you could write this one, but I like seeing this because it really shows me you did cancel. It's just, there's so many ways you can write things sometimes. Alright, you try number 11. Okay, let's look at this one. We're going to distribute. So I'm going to get 24w minus 36 equals, I'm going to distribute here, 24w minus 30 minus 6. Okay. I'm going to combine like terms. So I'm going to get 24w minus 36 equals 24w minus 36. They match. So you can write infinitely many solutions here. Wow, my y got a little crazy. Or you can subtract 24w on both sides. You can have negative 36 equals negative 36. Or you could add 36 to both sides and get 0 equals 0. Which are all true statements. This one, and that one, and that one. So infinitely many solutions. Okay? But you can't really be here. Don't do that. Be here and say infinitely many solutions. Not quite. You're not quite there. You need to at least get them to match. Alright, I think I got one more for you. Number 12. Last one. Pause the videos. See what you can do. Alright, 2n. Maybe. The board not going to participate. There we go. 2n minus 16 plus 7 equals 9n minus 12 plus 30. Combine like terms, these guys. 2n minus 9. Combine these. 9n minus 9. I'm going to move my variable. I want to move the 2n. I like keeping my coefficients positive, but that's just me. 7n minus 9. I'm going to move this minus 9. I'm going to add 9. And here again, people freak out. Negative 9 plus 9. What did I write? Negative 9 plus 9 is 0. 0 equals 7n. Notice my variable is still around. If my variable is still around and my variable hasn't canceled out, this is not special. This is one answer. I'm dividing by my coefficient, dividing by 7. 0 divided by 7 is 0. So I have one answer. One solution and a 0. Nothing special. Now technically, not technically, you don't have to write this. This is what you need. Okay? You don't need to write one solution. There is one solution. The special ones are when there's no solution to infinitely many solutions, you gotta say something about it. Okay? With this, you don't have to write one solution. I just wanted to write it because that is what it is. Alright, I think that's it. Let's double check. Alright, that's it. So you're going to do part of the homework. You're not going to do all the homework. You're going to do part of it. There is a review section. Do some of the review. Do the problems that match with this. And then take a break. Take a breath. And then do something else. Okay? Do something fun. I'll see you later in the next video. Goodbye.